Hi guys, welcome to the recorded class of Class 9 Science. I will be your science teacher for this academic year. When time goes on we will be knowing each other more and we will have fun learning science together. Our topic is matter in our surroundings. So what is matter? Everything in this universe is made up of materials which scientists have named matter. The air we breathe, food we eat, stars, plants and animals. Even a small drop of water or a particle of sand, everything is matter. One thing common to all above this is they all have mass and volume, i.e. they occupy space. Hello everyone. I am Noble and in this video we will discuss some important characteristics and states of matter. Anything that has mass and takes up space is called matter. So what are the different states of matter? Matter exists in three different common states. A. Solid. B. Liquid. C. Gas. Solid will have a fixed shape and in fixed volume. Liquids take the shape of the container but the volume remains the same. Gases on the other hand tends to take the shape of the container and the volume of the container. The next question that obliviously comes is these states of matter interchangeable? Yes, the states of matter are interconvertible. This conversation is possible by the temperature or pressure or both. Some common term used to describe the change from one state to another are 1. Fusion. Fusion is the change of state from solid to liquid. For example, solid wax becomes liquid or molten when heated. 2. Solidification is the change of state from liquid to solid. 3. Vaporization is the change of state from liquid to gas and condensation is the change of state from gas to liquid. Sublimation is the change of state from solid to gas or vice versa without going into the liquid state. For example, the burning of candle. So what is the matter made up of? It is made up of tiny particles that the scientists have agreed to call as atom. These tiny particles are not visible with our naked eyes. So what are the characteristics of these tiny particles? Take 1 teaspoon of sugar and add it with 1 glass of water. After some time the water appears to be sweet. This proves that water particles have space to accommodate sugar particles and both particles are moving continuously. The rate of sugar dissolving increases with either steering or by providing heat. This is because the particles move faster when there is rise in temperature. The particles attract each other. The strength of attraction is different for different matters. So what makes the state of matter different from each other? Their particle behavior, of course. Solids have an orderly arrangement of particles and they tend to have maximum force of attraction between them. The space and kinetic energy is least and they resist any kind of force that try to change their shape or their volume. Liquids in the other hand have particles that slips and slides between each other. They have intermediate force of attraction between the particles. The space and kinetic energy between the particles is medium. This behavior makes the liquid to take the shape of container. In the gaseous state there is no order. Particles move randomly, there exists minimum force of attraction between these particles. There exists a large space and maximum kinetic energy between the particles. So what is the effect of temperature on the particles? The increased heat energy due to the rise in temperature increases the kinetic energy in solids. This increase results in particles vibrating in high speed. The energy supplied by heat overcomes the force of attraction between the particles. The particles leave their fixed position and a stage is reached when solids melts into liquids. Same way, if more energy is given to the liquids they tempt to move more freely and are converted into a gaseous stage. The reverse process has occurred when gas is converted into liquid and liquid to solid by decreasing the temperature by removing the heat. The temperature which a solid melts to become a liquid is called melting point. The amount of heat energy that is required to change 1 kilogram of a solid into a liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Because of this latent of fusion, the particles in water at 0 degrees centigrade do have more energy as compared to the same particles of ice at 0 degree temperature. So what is the effect of temperature on the particles? The increased heat energy due to the rise in temperature increases the kinetic energy in solids. This increase results in particles vibrating in high speed. The energy supplied by heat overcomes the force of attraction between the particles. The particles leave their fixed position and a stage is reached when solids melts into liquids. Same way, if more energy is given to the liquids they tempt to move more freely and are converted into a gaseous stage. The reverse process has occurred when gas is converted into liquid and liquid to solid by decreasing the temperature by removing the heat. The temperature which a solid melts to become a liquid is called melting point. The amount of heat energy that is required to change 1 kilogram of a solid into a liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Because of this latent of fusion, the particles in water at 0 degree centigrade do have more energy as compared to the same particles of ice at 0 degree temperature. The next thing is the boiling point. The temperature at which a liquid starts boiling at atmospheric pressure is called the boiling point. Latent heat of vaporization is the heat energy required to change 1 kilogram of a liquid to gas at its atmospheric pressure at its boiling point. This makes the particles of steam, that is water vapor, at 100 degrees centigrade to have more energy than the water at the same temperature. So now let's see the effects of pressure on states. Gases are converted to liquids for easy transportation. Now this conversation is possible by decreasing the temperature and increasing the pressure. This process is also known as liquefaction. Dry ice or carbon dioxide is converted into solid state under very high pressure. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure without coming into liquid state, and that's the reason why carbon dioxide is also known as dry ice. So what's the difference between boiling and evaporation? Boiling is a bulk phenomena. Particles from whole of liquid. Let's say some water is boiling, the particles from whole of water can change into vapor state. On the other hand, evaporation is a surface phenomena. Particles from surface only gain energy to convert into a vapor state. What are the factors affecting evaporation? The factors affecting evaporation are, the first, surface area. We already talked about that. Evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying, we spread them out. Then the temperature. An increase in temperature, more number of particles gets enough kinetic energy to go into vapor state. Therefore, an increase in temperature increases the rate of evaporation. Decrease in humidity. Humidity is the amount of water present in air. The air around us cannot hold more amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. An increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Thus, the rate of evaporation will increase. Guys, hope we had a good class today. Please keep checking your apps for notes and assignments.